Good afternoon, everyone. It is my pleasure to introduce Dr. Rakesh Kumar Sanodiya, who serves as an assistant professor and wait a second. Mm. It is my pleasure to introduce Dr. Rakesh Kumar Sanodiya, who serves as an assistant professor and head of computer science and engineering discipline at Indian Institute of Information Technology, Jabalpur. Dr. Sanodiya earned his PhD in computer science and engineering from Indian Institute of Technology, Patna, where his research focused on metric learning with applications in clustering and classification. His research interests span machine learning, deep learning, robotics, intelligence, and AI ML applications, including areas such as transfer learning, domain adaptation, and reinforcement learning for navigation and object manipulation. He has published more than 27 SCI index journals and 32 reputed conferences and one patent. Under his supervision, two students have completed their PhD. He has also actively organized research workshops such as Wadla 1.0, Wadla 2.0, and Wadla 3.0. Dr. Sanodia has been recognized with several accolades, including awards from the Smart India Hackathon and the Intel Higher Education Challenge. Today, he will be sharing his expertise in deep learning, offering insights that are particularly relevant to students and enthusiasts in the field. Please join me in welcoming Dr. Sanodia. Mic to you, sir.
Uh, thank you very much, Gaurav, for introducing me. So, welcome to our second session of day one, uh, summer school on deep learning, shaping the future of AI. So, I think, uh, okay, now I'm sharing my slides. Is my screen visible? Okay, yeah. So, So basically, this is today. Basically, we are going to see some basic concepts which are very important before learning. Before I deep you dive in deep learning, so some maths and NumPy and PyTorch. So what are those things? Basically, we are going to discuss in today's module. So basically, I am going to cover two modules. So in this module one, we have a around 12 sub-modules. Okay, so basically each module is going to cover each topic. Okay, so while preparing the content of the today's talk, so I would like to acknowledge to Mike X Cohen's Master Deep Learning course, which is available in Udemy. And I also have taken help of ChatGPT, Grok, all the AI tools. So along with other sources also, I have taken while preparing the slides of today's talk. Okay, so first submodule is spectral theories in mathematics. So we will see what is basically the spectral theories in mathematics and how it basically plays the role in mathematics. Okay, so in these modules, so basically you will explore the meaning and significance of spectral theory and how artificial neural networks related to the spectral theory and the difference between the complicated and complicated system and why basically we are going to call deep learning is simultaneously easy, complicated, and complex. Okay, so spectral theory basically involves breaking down the very complex structure into simpler individual components, making them easier to analyze and understand. Okay, so here basically you take a very complicated structure or problem and you decompose it into a very simple problem so that you can easily analyze and understand. So if you are from the computer science background, so you might have seen, right, so how basically the merge sort, quicksort algorithm works. So these algorithm also basically take a very complicated problems, right, and very big problems, and slowly, like in each and every time, it try to decompose it into a very small problem, right? So once if you get the small and a solvable problem, then again you start combining it. Okay, so then this is the way these algorithm basically take a very complex problem and solve by simplifying it into the very simpler problem. So here also the same way the spectral theory does here. Okay, so now the question is, so where basically you use this spectral theory. So spectral theory is used in support vector machine or singular value decomposition, and in Fourier transform, right? So all these are the basically the applications where you can find this spectral theory concept. So how this spectral theory is related to the deep learning? Okay, so that the answer of these questions I will give you after 2 and 3 minutes. So now this is basically the illustration of very simple deep neural network models. So here you can see, right, so here you can see, so these are basically the input layer, and these are basically the hidden layers. Okay, and this is basically your output layer. Okay, so here each unit, okay, so in this model each circle is representing basically a one neuron, or you can call it as a perceptron, or basic unit of a artificial neural network models. Okay, so this is this x0, x1 and x2, this is basically the input feature vector. Okay, and then so the each and every arrow which you are seeing this here, okay, so they basically in this arrow usually you are going to have some weight vector. So usually we represent it by the W. Okay, so this kind of illustration basically hides the simplicity of the model, means what is happening at each individual unit. Okay, so in each and individual unit, basically implementing a very simple mathematical operation, okay, which is a dot product. So as I told you, right, so here, so this is the W. The W is basically the associated weights, okay, all these arrows and the input. So here you can see x0, x1 and x2. So basically all these input along with this weight, they are passing to each and every unit. Okay, so this is a one neuron, and this neuron is implementing a very simple mathematical operation, which is a dot product. And the result of this dot product, okay, x transpose W is passed through a very simple non-linear operation or non-linear function. Okay, so basically in each neuron, basically two mathematical operations you are performing. One is the dot product. So as you can see, x transpose W, and the result is being passed through the one non-linear function, which is a sigma here. Okay, so now you can say the entire maths of the deep learning can be decomposed into two simple operations. One is dot product and another one is the non-linear operation. Okay, so now you can see, the deep learning is very easy. Why it is easy? Because it is implementing a very two simple operation, which is one is the dot product and another one is the non-linear function. Okay, now coming to the difference between what is basically the complicated and complex. So complicated means it is going to have a lot of parts, okay, and the parts like it is going to be linear, more linear, and few non-linearities, and it is basically the intuitive and understandable. So if I take an example like a car, right? So car, basically, if you are from an engineering background, so definitely you can see the functionality of each and every part of the car, right? So by seeing all these components or all these parts of the car, right, if you are from the engineering background, so intuitively you can understand what is the functionality of all these components or all these parts, right? It is intuitive, right? So similarly the phone as well, right? So if you know, if you are from the engineering background, so easily you can understand the, you know, the functionality of each and every component. Okay, so then coming to the complicated, basically it has a very few parts, okay, and most of the parts are the non-linear, okay, and it is basically the counter, unintuitive, difficult, and impossible to understand. Okay, if I take an example, right, so biology, or like if we take your mind, right, so your mind or your brain is going to have many neurons or many cells, right? So like, you know, like if I say that what is happening in your mind, okay, so you may not be able to understand just by seeing the brain. Okay, so each and every brain is going to have the different functionality. So now you can say that, you know, your brain is basically the complicated. So this is basically the difference between the complicated and complex. Sorry, here it is basically the complex here. Sorry, mistake here. Okay, so now another example. So here difference between the complicated and complex. So here basically three very simple equations are shown, right? So but so by seeing and by nature, like, you know, the equations which are shown are very simple, so easily you can understand them, right? But if you draw a movement of a particle along these three axes, x, y, and z coordinates, then you will get uh, you will get this is a very, you know, complicated Lorentz or beautiful butterfly system. So by seeing this equation, you cannot predict or you cannot understand that this is going to form, this is a very complicated, you know, butterfly here. Okay, so here also you can say this is the difference between the complicated and complex. Okay, now after seeing all those examples, so we can conclude that the deep learning is simultaneously simple, complicated, and complex. Why it is simple? Because it is made of simple and easy maths, right? What are those maths operations? So entire maths of the deep learning, you will see that it can be broken down into two simple operations, right? So dot product as well as the non-linear function. And why it is complicated? Because it contains many parts. So you will see, right? So when you are going to deal with a very complicated problem, so you will find that, you know, you are going to have many neurons and many units. Each of these units basically implementing very simple operations, right? So then why it is also complex? Because of merit non-linearity, and because it is unintuitive and difficult to understand, like black box, as I told you, right? So brain, by just seeing the brain, or but by just if I show you a very complicated model, right, so you may not be able to understand, right, what would be the behavior, whatever the input you are going to give the model, that you cannot just understand that what basically it is going to reply to you. Okay, so that's why, so deep learning is simple, complicated, and complex. Okay, so now in these modules, right, so you have learned, right, so the meaning of spectral theory and its relevance, and how artificial neural network relates to the spectral theory, and difference between the complicated and complex, and why deep learning is simultaneously easy, complicated, and complex. Okay, so I think we have some few questions. 1 minute. Participant. Okay, I will take all the questions after some times. Okay, just wait. Okay, now let's have some cues. Okay, so simple cues here. Okay, so I expect you that you just note down on the chat box, right? So what is the core idea of the expector theory? Can anybody give the answer? Okay. Yeah, so first, as we have seen, you have already seen in the definition, right? So breaking down the large problems into smaller and manageable components. Okay, now the second question, why is deep learning considered as a simple at a fundamental level? Yes, again, its answer is the dot product and non-linearity. Okay, so now the third question, simple question is why deep learning considered as a complicated? Why deep learning is considered as a complicated? Because it consists of many parts. Yes, again, this is right. And why is the deep learning considered as a complex? Yes, the answer of this question is again, yes. Yes, so it is, now you can see all the answers here, right? So I hope now you have successfully learned the first module of this module. Okay. Now coming to the second module, right? So the second module is terms and data types in math and computers. Okay, so in this modules, basically you will learn some important terms in linear algebra and data storage and types of numbers and variables. Okay, so linear algebra terminology, right? If we talk about you might have already seen this single number, scalar number 7, right? And you might also have been familiar with this some vector, and also you might have seen this the 2D matrix, and also you might have seen some high dimensional matrix. Okay, so in linear algebra terminology, what basically each and every object you basically call, if it is just a simple number, right? So then you call it as a scalar, right? If it is a some numbers which are in some column or some row, right? Some group of number, then you will call it as a vector. Okay, if you see that you have a collection of this kind of numbers, right, in a 2D array, 3D array, right? So then you will call it as a matrix, right? And higher than 2D, then everything you will call it as basically the tensors. Okay. Okay, so now coming to the point that how basically the means I would like to ask you that basically how your images is stored in basically the computers, right? So you might have already seen that the images could be of two types, right? First is the grayscale images and another one is the color images. So if we talk about this one grayscale images, if you take a very small portion here, right? So if you take a very small portion, you already know, right? So the images basically consists of many pixels, right? So here, if we have taken a very small portion, right, and if you just draw it, so you will see that this particular portions nothing but a one matrix which is going to have some numbers. Okay, so each pixel of this particular portion basically is going to have the number between the 0 and 255, right? If, like, you can see here, here you can see that this is a totally white, right? If it is a white, then the number will be higher, so maybe it may be near to the 255. If the portion, like the pixel, if you see it is a black, so then it will be near to the 0. So as you can see that here it is basically the 0. So similarly, like the portion of this each and every images can be represented by using a one matrix. Okay, So here also, like we have just drawn this particular matrix over here. Okay, so now similarly, if we talk about the color images, right? So this is a one channel. Okay, so grayscale basically consists of the one channel, and color images consists of the three channels. Okay, so then this kind of layer, whatever we have shown in the grayscale, so it is going to have three layers, or three basically the the three channels here. Okay, so one is going to represent the red color, another is going to represent the blue color, another is going to represent the green color. Okay, so this, and same, the number will remain the same here. Okay, so this is the way basically you convert the images into this kind of matrices, and this matrix basically is stored in your computer. Okay, so what is the basically the data type then in computer science? So data types in computer science basically the way of storing the data. Okay, and you can say sometimes the format of the data storage, basically how you are going to store your data in the memory. Okay, and well, let's say if you are going to create any variable, okay, or if you would like to store any data, so first you have to allocate the memory. So what kind of data it is, whether it is a some string data, character data, or some numeric data, right? So of course, like for storing the data, so you have to reserve some memory, right? So you definitely, with the help of this data type, right, so you are going to tell to the computer, okay, so right, so I am going to have this kind of variable, this kind of data, so you accordingly you basically reserve the space. Okay, but coming to the statics, right, so the data types in the statistics, it is basically the category of the data. Okay, so and so what are the basically the implications? Okay, so now in the different data, so you can perform the different operation. Okay, and different data types is going to have the different basically the storage space. If we talk about the character, right, so character, if you are going to create a one variable of the character, right, so char, and a, if you write, right, so the variable a has been created, and how much data it is basically going to take, maybe 1 byte, right? Similarly, let's say integer a you have created, right? So then definitely for this particular, because it is an integer type, so for that particular variable, so it is going to uh, uh, it is going to give you the 2 byte of memory. Okay, so what are the example of the data types, right? So floating point numbers, booleans, right, and strings. Okay, so these are the basically the data types. And similarly, if we talk about the statics in the data types, so it is basically the category of the data. So here, what are the implications? So what appropriate statistical algorithm or procedure you can apply on that particular data? Okay, so different data types will come, different static algorithms are there which you can apply on a specific data type. Okay, so that is basically the implication here. And are the examples here like categorical data, numerical data, and ordinal or ratio data. Okay, now again, so data types in computer science. So now you can see, right? So if intuitively, like you can understand here, right, 4 and 4.0, the meaning is equal, right? For both the numeric value are representing one numeric value, which is 4, right? But the way they are storing, right, so this is, you can see, this is basically the integer, and this is, you can see, the floating point number, right? So definitely, so this variable 4 is going to occupy, let's say, some 2 byte data, occupy 2 byte space, and this 4.0 is going to take some, because it is a floating point representation, so definitely it is going to take like 4 byte or some more spaces as well. Okay, so on these, like so what are the implications here again? So storage space you have already seen here, and operations, right? So on let's say if you perform some addition operation, right? So if you want to perform some addition operations, so definitely it should be the data type of those operations should be same. So you cannot perform addition between the some integer data with the some character data. Okay, so these are the basically the operations you can perform. So here you can see, so this is right 1 2 3. So this you will call it as a list. Okay, this is the number, they are representing the same number, right? But the different terminology, you are going to represent them in a different way. Okay, so this is the list. This is basically the array, NumPy array. Okay, and this is basically the torch, right? So this is basically the tensor. So in the tensor, when we come into the tensor, basically the library, this is the tensor is basically the one of the important, like everything in torch, you can represent every object, whatever the object is there. Okay, whether it is a scalar, whether it is a vector, whether it is a matrix. So everything will be represented by using the tensors in the torch or high level libraries such as TensorFlow. Okay, so now here you can see, so how basically in different frameworks you are going to call these object differently. Okay, so let's say here the 7 is there. So in math usually you call it as a a scalar. In NumPy you call it as an array, and in PyTorch you call it as I told you, right? So in high level languages, libraries such as PyTorch or TensorFlow, everything you will call them as everything will be treated, whatever it is here, whether it is scalar or array, so they will be treated as a tensor. So again, you can see here in math, this particular vector, this is a vector, and NumPy, it will be treated as an array, and then in tensor, again, it will be treated as a tensor. So here the matrix in NumPy, ND matrix, and PyTorch, it is a tensor. Again, this is also the tensor, right? This is basically the multi-dimensional array in NumPy, and here in the PyTorch, you can see this is again, it is a tensor. Okay, so now in this some modules, you have learned some important terms like in linear algebra and data storage, okay, and types of the number and variables. Okay, now coming to the questions. Okay, now this is the Q2 of this particular submodules. So what is a scalar in mathematical terms? Okay, so many of you are saying that scalars are single numeric value, correct? Okay, yes. What is the second question? Which of the following is an example of one-dimensional data structure? Yeah, vector, right? So yeah, now the third is which data type represents multi-dimensional arrays used in the deep learning? Tensor, very good. Yes, now you can see here it is basically the tensor. Okay, so now what does the term data type refer to in computing? Yes, definitely. The kind of value a variable basically the holds. Okay, so which of the following is not a numeric data type? String. Yes, definitely string is not basically the numeric data type. Okay, so yeah, so now these are the basically the all the answers. Okay, so yeah, this is just brainstorming. So whatever I have basically the taught to you, whether you have got it or not, so to keep you active, so that's why we have kept one simple quizzes, so that you would be active and respond the session. Okay, now coming to the third submodule of this session, converting reality to the numbers. Okay, so in these submodules, you are going to learn how to represent real world outcome using numbers. Okay, and also we will see the difference between dummy coding and one-hot encoding. Okay. Okay, so now basically the two types of reality is there, like, so in day-to-day life, right? So, so each and every quantity, right, so which you are seeing, so can be categorized into the two types. So first is the continuous and another one is the categorical. So continuous means, like, it is basically the numeric value, right? And the many and possibly infinite distinct value may be possible. Okay, so for example, height, right? So height you might have seen, right? So height may be like, it is basically the continuous data. It can be any, like 2 point means like 5 feet 6 inch, 5 feet 6.1 inch, 5 feet 6 to 6 inch, right? 6'3", 6'4", 6'5", right? So this basically, what is basically this one? So this is a continuous data and infinite value will be possible, right? Similarly is exam score, right? So that you can score the numbers between the 0 to 100. So there would be infinite values are possible, right? So that's why you are calling it as a continuous, right? So that kind of reality you might have also seen. Also the example like income. So people's income also, it is a type of, continuous, right? And review score. Okay, so all these, like whatever you see in the real time observe, right? So those kind of data are basically the numeric data. So coming to the categorical data, so it is a discrete, right? So some interval the data would be there and very few value would be there, right? If we talk about the uh, uh, in any subject, so what grades basically you have obtained, right? So the grades may be finite, right? Maybe O, A plus, B plus, C plus, D plus, and directly then F fail, right? So these are the only finite possibilities, right? So similarly, like in a picture, like if I show you one picture, right? So you have to just see that whether what is there, whether it is a cat there or dog is there. Okay, so there would be only two categorical, only the finite values are there, right? Similarly, disease diagnosis, whether there is a disease or not, yes or no, right? So this type of data comes under the categorical data. Okay, now in order to how this categorical data you can represent. Okay, so yes, so I have a disease. Okay, the means like whether you have watched the movie, yes or no, right? So these are the conversation for your day-to-day life, right? But you know that machine these conversations cannot easily understand, right? So machine just knows the binary languages, right? So 0 and 1. So these observations, right? So you have to how basically you can teach or how basically you can feed to the computer, right? So these observation, yes or no, pass, fail, okay, so what grades you have obtained, so you would like to feed to the machine, right? So how you can represent those things, so then you have to take help of some dummy coding or one hot encoding. So dummy coding, right? So you can just whether you have fault if it is false or true, right? So false can be represented by 0 or true can be represented by the 1. Okay, and you can also create a single vector, right? And for example, exam whether you have passed or failed. If you have passed, so I can tell that okay 1. If you have failed, then I can denote it by the 0. So these inputs along with your roll number, right? So those things can be given to the computer. Okay, so similarly in one hot encoding, so 0 or 1 per category. Okay, here basically you are going to have the one matrix. Okay, so example like image recognition, right? So let's say handwritten letter recognition. So definitely, so when you are going to write any letter, right? So definitely it may be from A to Z, right? So finite possible means like 26 possibilities are there. Okay, so let's say if I have written like A or if I have written C, so then corresponding 3, right? So then you have a one vector of like if you have 26 letters, right, in your English alphabet, so then vector size for each letter would be 26. Okay, so then in this particular vector, third, like since this character which you have written is a C for cat, C, so then corresponding entry would be 1 and rest of the entries, right, would become the 0. So similarly, another character you have taken, let's say it is a E, right? So it is a fifth character, right? E, right? So then again you will have to take the one vector of size 26 and the fifth entry will become the 1. Okay, and then rest of the entry will remain the 0. Okay, so then here corresponding to each category, right, you are going to have the value 1. Okay. Okay, so now here is the example, dummy encoding, right? So dummy encoding, right? Reality, the student has passed or failed, right? So if he has passed, okay, so then what you are going to do here? So corresponding entry, okay, so you are going to tell, so this is for your observation, right? So these, as I told you, right, so this observation cannot easily be understood by the computer. Okay, so that's why you basically try to give this kind of dummy coding. Okay, if he has passed, so you are going to denote it by 1. If he has passed, again 1. And if he has failed, 0. Okay, so then this data, this vector, okay, so this particular vector along with this reality you are passing to the computer. This is in case of the dummy coding. Okay. In case of the one hot encoding, so one hot encoding, so let's say, so there is a one movie, right? So different movies are there. So you would like to know, so there are 3 possibilities. Okay, so the movie can belong to history movie, can belong to sci-fi movie, and can belong to kids movie. Okay, so now if the movie belongs to the sci-fi, right, so as I told you, right, so whatever the options are available, so in the previous examples, as I told you, right, so in alphabets basically you have total 26 letters, right? So that's why you have taken the vector size of for each data samples 26. So similarly here you have also how many categories? Also only 3 categories, right? So then you have to, for each and every samples, you will have to take the size of 1 cross 3. Okay, so let's say if this particular sample, okay, belongs to the sci-fi, so then corresponding entry you are going to make it as a 1. Similarly, for after watching this movie, so now you realize that it is a kids movie. Okay, so then this belongs to corresponding entry you are going to make. Again, the size would remain the same here. Okay, for third one, it is a history movie, then this is the, okay, so now this information, okay, so this is basically you call it as a one hot encoding, and then this is basically the corresponding to this movies. So this vector basically you are going to pass. Okay. Okay, so now in this module you have seen how to represent real world outcome, right? So using the numbers, and also we have seen, right, the difference between the dummy coding and one hot encoding. Okay, now the cues for this particular sub modules. So now you tell me, in machine learning, converting categorical variables like red, green, blue into number is called as what? B, yes. One hot encoding, yes. Okay. Now second question is, what kind of variables are converted to numbers using encoding scheme like encoding, level encoding, and one hot encoding? B, yes. Categorical variables, yes, correct. Now third one is, which real world object is best represented as a time series when converting to numbers? B, no, photograph is wrong. Time series, yes. A weather log recorded hourly. Okay, so now next is, what is the main challenge in converting reality to numbers? Data storage or preserving inter interpretability or context? Yes, so B is the right answer. Okay, preserving interpretability and context, because when you are going to convert your reality to the numbers, so definitely you would also have to preserve the context. Okay, what basically the context the reality is presented, so same context should also be remain same when you have converted into the numbers. Okay, so now the next question is, which of the following is an example of converting qualitative data to quantitative data? Yes, option A. Yes, assigning 1 to yes and 0 to no, right? So here you can see the qualitative data, right? So you have converted quantitative data, right? Okay, so these are the basically the answers. Okay, so now next move on to the next sub modules, vector and matrix transpose. Okay, so in this some modules, basically you will learn how to interpret and use the transpose operation. Okay, so transpose you already know, right? So since beginning, means in your school level mathematics also you have already seen, right? So how basically do the transpose of the vector. So here you can see here one column vector is given, right? So once if you perform this transpose, so all columns will becomes the rows. So here you can see now all the column vectors are converted to the rows vector. Okay, so then again, if you take one more time the transpose, right? So again, this particular, so you will get the same. Okay, transpose of transport is nothing but the same vector. Okay, so that you can see it here. Okay, so now transposing of a matrix, right? So in the transposing of the matrix, so what will happen then here? So transposing of the matrix means all the columns will become the rows and all the rows will become the columns. So now you can see earlier the rows is there like 1 5, it is a row. Now you have transported to the column, right? So just transposing the rows by column, right, and column by rows. So this is the, again if you take one more transpose, so again you are going to get the same matrix, 2D matrix here. Okay, so now because this is basically the practical session, so now I'm going to take uh, means a Google Colab. So I think you can also do parallelly the coding with me. Okay, so because I want that you should have more and more hands-on session and you should have more and more practice how to write the code, all those things, right? So maybe you can also, I think you might have already watched the pre-recorded video. So where how to install the Anaconda and how to make the environment for running this PyTorch or TensorFlow libraries, right? So those you might have watched. Otherwise, what you can do, so you can parallelly you can do the coding with me in the Google Colab. Okay. So in this particular, two links are there. So okay, I will share with you this particular you know slide with you. So parallelly also whenever I have a last time, so they like this course like which I have taken from that Udemy course. Okay, so directly you can we can run those codes because it is accessible to you, and you can observe, like you can change some portion of the code and you can see the effect, so you can easily understand it. So when we have the last time, otherwise live I will do the coding here. Okay, so I am going to create a one vector, then performing these kind of transpose, dot product, okay, matrix multiplication. So all those operations basically we will see here. Okay, so here so here you can see this is basically the Google Colab, right? So in this Google Colab, so you need not to install any libraries until and unless it is required. Okay, so most of the works basically you can do here. Okay, so most of the functions basically you can directly implement here. Okay, you need not to install anything, but yeah, some libraries, like some of your program, if which it requires some explicitly libraries, then you will have to install in this particular framework. Okay, so why this Google is so convenient, because it provides the GPU as well. Okay, so go to the runtime. Okay, so here, so change runtime type. So here you can see it is supporting the Python 3. Okay, so it can also support some other languages as well, like R, Julia. Okay, so here, so the configuration, if you change, let's say if you have very simple program, right? So just if you are performing some addition, multiplications, okay, so which does not require high computational resources, so you can use this GPU environment. Otherwise you can use this T4 GPU, right? So which is publicly available without paying. Also it is also having V28 TPU, right? Tensor processing unit, and graphic GPU. GPU is there, and 800, but you have to purchase this other for activating other GPUs here. Okay, but if you use this configuration, so then high computational, the program which require high computational at the back end, so those program can also be run. Okay, so those things also we will see in the upcoming lectures. Okay, so right now, because we don't require, because we have not yet implemented any deep learning any program, so better you use this CPU your configuration. Otherwise if you are using your some deep learning, if you are implementing, so then you can use this T4 GPU. But one thing here you have to remember that, okay, so only for some hours it provides you freely. Okay, maybe 2 hours, 3 hours. After these hours, right, it would be exhausted. Okay, you may not be able to use for one day something. Okay, so remember this thing. So they are not fully freely available all the time. For some unit of time, let's say if you can use it for 2 hour, 3 hour. Okay, then again you will come back to the CPU all the time. You can use the 24 hours, you can use CPU. Okay. Okay, so now two important libraries here. So first is I hope you already familiar, because we have already recorded the videos and uploaded. So import numpy as np and import torch. Okay, so this is the PyTorch library, basically the torch, right? It is going to have many functions, so that we will see one by one. And this is basically the numpy library, so for performing some dot product, for creating the vectors. Okay, so all those operations can be performed with the help of this numpy library. Okay, so now, so first, because yet your this code, whatever you have written, this environment is not connected to the backend, so then you have to here manually. Now after changing the configuration, runtime configuration of your system, this Google Colab environment, so now you have to click on this connect. Okay, so once if it is connected, okay, now you can see, now you are connected. Now it will see you the configuration of your machine here. So now you can see your allotted, okay, you are using Python 3 Google Computer Engine backend, showing resources since, right? And then you can see, system RAM, which is given to you 12.7 GB, right? And now currently you are using only 1.0. And how much hard disk they have given? So that much data you can keep it here, 107.7 GB. And out of this 107.7 GB, you are using this 37.3% only. Okay, again, if you would like to change the configuration, right, so you can change. Then you will see here the GPU will also come at this particular place. Okay. Okay, now, so now if then this is particular cell, you here you can write the code. So here at a once you can run all you know, whatever the you know cells you have created here, or one by one also you can you know, run it. One cell you write and then run it, and then you go to the next. Okay, so if you just enter shift and enter. Okay, so then what does shift and enter? Remember, shift and enter. So what does it mean? So means you are running the current cell and you are switching to the next cell. Okay, so if you enter both at the same time, shift enter, you are running the current cell and moving on to the next cell. Okay, so now these libraries now you have imported. Okay, so now what you want now you want to create a vector. So let us see how basically you can create a vector in NumPy. Then we will see that how basically you can create a vector in the PyTorch. Okay, so create a vector. Okay, so now let's say NV. So here NP, right? So because NumPy, with the help of the NumPy, basically you can create the vector. So array. Okay, so then because one dimension vector, so 1, 2, 3, 4. So this is basically the one dimension vector. Okay, so you can also print it. So if you print it, so sorry. So now you can see this is a one dimension array has been created, right? So it is a one dimension vector. If you take the double matrix here, okay, two brackets here, so then it is a basically a matrix. Okay, and this is basically going to represent what? Basically one row. Okay, so now you have taken a matrix. Okay, so this particular number, okay, whatever you have taken, okay, so this is a one row. Again, let's say if you want to create a two-dimensional vector, right, a 2D matrix, so then again you can take it here, 5, 6, 7, 8. Okay, so now you can take it here. Now 2D array. Now 2 rows are there, and how many columns are there? 4 columns are there. Okay, so here also it can be presented here. Okay, so now I wanted to tell you that how basically you can perform the transpose here. Okay, so now to perform the transpose basically, so let me first print it, print NV. So this is just for the giving the space. Okay, so now transport it. So for transposing it, so what you can do, print nv.t. Okay, just you need to write the t. So if you just write to the t, so then you will see, okay, so all the rows will become the columns and all the columns vectors will become the rows. So now you see, so this NV, this is basically your 2x4 vector, right? 2x4 matrix. Now here you can see 4x2 matrix here after performing the transpose here. Okay. So then again, if you would like to perform transpose of the transpose, right? So again, if you perform this thing, nvt is equal to nv.t, right? So nvt, so what you are trying to do basically, you are transposing it, then again you are transposing it. So what is the result basically that you have seen? What result basically you will get it here? Yes, original matrix. Okay, so again you will get it the original matrix here. Okay, so the same thing you can do with the single one vector itself also. So here I have taken the example of the two-dimensional 2D matrix here. So you can three, four, whatever dimensions you would like to take it here. Okay, so same things. What I'm trying to do here, I would like to do using the PyTorch. Okay, so using the PyTorch basically NV. So how basically each and every in the PPT I told you, right. So whether it is a vector, whether it is a scalar, whether it is a 2D matrix, whether it is a high dimensional matrix, everything is a tensor. Okay, here also if you see here, NV is equal to torch dot tensor. Okay, so here, because now what you are trying to do, so matrix you can take, so one dimensional matrix you are taking 1 2 comma 3 comma 4, sorry. Okay, so now then how basically here you can perform again the transpose. Now transpose it, so print nv dot t. Okay, so then again if you take transpose the transpose nvt nv dot t, then print nv dot t. Okay, so here you can see, so here basically the matrix, because two square brackets you have seen it here, right. If you have just taken, then so it is a matrix, right, only it is having the one row, right. So this is basically the one row, 1 2 3 4. Okay, so now if you take the transpose, so definitely now you can see, so here each row, like each element now has become the one column here. Now you can see this is basically the 4 cross 1, sorry, here it is the 1 cross 4 matrix, here the 4 cross 1 matrix, right. So then again I have taken the transpose, right. So now you can see that each and everything, the data, right, whatever the data you are writing, so all these things are basically the tensor over here. Okay, okay, so similarly if you take the multi-dimensional as well, let's say nm is equal to torch dot tensor 1 2 3 4, right, again 5 6 7 8. Okay, so that this is a 2D array, right. And you transpose is print nm dot t, then again if you transpose it nmt nmt. Okay, now you can see after transposing two, here how many rows were there, 2 rows were there. Now you can see 4 columns are there and 2 rows here, right. Here 2 rows 4 columns. Okay, so again if I have taken the again transpose, now you have got the original matrix. Okay, so this is basically the transpose of this thing. But now you would like to see, all this data types, what are basically the data types of all those variables. So how basically you can see types. So print, so here f variable. So what are the variables? Basically first variable you have taken nv is of type, so type. Okay, Okay, so now first variable data type you would like to see. So what is basically the data type? Okay, so now here you can see small v, because this is a numpy array, right? So now you can see the what is the data type here? ND array. I told, right? So in the numpy it is a ND array, but now you have created this NV, right? So what is basically the data type here? Tensor here. Okay, so everything in the PyTorch, basically every whatever the quantity you are going to define, so they will be treated as a tensor. Okay, so everything you have to convert into the tensor, then only you can process the data. Okay, so here again, right, this multidimensional, you would like to see the data type again. So print. Okay, so this even the multidimensional data array means tensor you have taken here. So it again it is a remain it will remain the tensor. Okay, so this is like why I am going to explain, because I also expect from you that okay, so you can understand, you can create the variables, right? You can perform some operations like transpose and dot products. Okay, so that's why you should do some practice on it, right? Okay, so now this is a transposing of matrix. Yeah, tensor, what is, as I in the previously also I have already discussed, like what is the difference between the numpy and torch, because when you are going to fit the data into your model, right? So deep learning model, right? So it will remain the too much size, bigger size. Okay, the data would the parameter would be more and more. Okay, so that's why each and every data type we consider in the PyTorch as a tensor as well. Okay, so I already illustrated the difference between NumPy and torch tensor. Okay, so now in this submodule, so you have learned how to interpret and use the transpose operation. Okay, so now the q is 4. Okay, so the transpose of the transpose of a matrix is basically what? Yeah, A itself. Yes, correct. Okay, now the second question is, sorry, what is the result of alpha A? Means A is your matrix and alpha is basically some scalar. And if you perform the transpose where alpha is a scalar and A is the matrix, then what is the result? What is the answer? B. Yes, correct. So there would not be change in the alpha. Okay, so just the matrix will be transposed. Okay, so a scalar will remain the same. Okay, so now next question is, which of the following is true about a vector? What is the answer? So this is a vector transpose into vector is a matrix. Vector transpose vector is a scalar, or vector transpose is always 0, or vector transpose is a vector. What is the answer? D. Yeah, which is basically the vector. Okay, so sometimes it may be scalar you may also get, or sometimes matrix also you may get. Okay, both the answer are correct. Basically vector, if you perform the dot product, right? So you may also get the matrix, or you may also get the some scalar value. Okay, so for two vectors like A and B, right? The expression like A transpose B is equivalent to what? What is the answer? Your answer? Fourth question, C. Yeah, dot product. Okay. And if A is the n cross n symmetric matrix, then which of the following is correct? Yeah, A transpose will remain the same, right? Okay, so these are the basically the answers. Okay, so moving on to the next sub module, right? So dot product. Okay, so I know that you already know, right? But I'm just going to do some hands-on, right? So practically you can work on how basically you can implement this particular dot product. Okay, so So in this sub module, basically you will learn various notation for the dot product. So how to compute the dot product in vectors and matrices, and why the dot product is so important in a human civilization. Okay, so the dot product, let's say A is a one vector, right? B is a one vector, right? So what you basically try to do, A transpose B, right? So A transpose B, when you perform, right? So what will happen, basically the corresponding values will be multiplied, then what are the results of those corresponding values, that would be added, right? So you will perform the summation. So if you see the example here, so here you have two vectors u and v, right? So then corresponding values, right? So one, like the first value of a vector v and first value of a vector w, you multiply them. Okay, then similarly, second value of the vector v and second value of the vector w, you multiply them. Then third value of the vector v and third value of the vector w, you multiply them. So you keep on doing like this. Okay, so then here you can see 1 multiply by 2, 0 multiply by 8, 2 multiply by -6, plus 5 multiply by 1, plus -2 multiply by 0. And then you add the result. Okay, so that is basically the dot product between v and w. Okay, so this you are doing, right? How you are doing manually, like performing multiplication operations and then summation operation, but this kind of things can be done in one shot. Okay, if you just do v transpose w, okay, so immediately all those operations you need not to worry, right? So you will result, this will result to the one scalar number, which is a -5. Okay, so similarly here, so what are the basically rules for this performing the dot product here? Like both the vectors should have the same size. If both the vectors will not have the same size, and even if you are performing the dot product, so it might be possible that you might get the error. Okay, so here also you can see one corresponding value 2, you can easily multiply. 0 corresponding value is 8, you can multiply. 2 corresponding value -6, you can multiply. But what about the 5 and -2, right? For those corresponding values are not there. Okay, so therefore you cannot perform the dot product here. Okay, you will definitely you will get the errors. Okay. Okay, so now what about the dot product between the matrix, right? In 2D matrix, right? So if you would like to perform the dot product between the, here I am not talking about the matrix multiplication. Here I am talking about the dot product. Okay, don't get confused. Okay, so here how you can perform the dot product in the 2D. So 0 will be multiplied corresponding 0th position of the another matrix. So 3 second position, right? So here also the second position. 2 will be multiplied by 6, -3 will be multiplied by 2, -3 will be multiplied by -1, 1 will be multiplied by 0, and 1 will again will be multiplied. So then you keep doing this thing for every values, and then whatever the result is there. Okay, so that is basically the result of the dot product. Okay, so then same thing how you can perform. Okay, so that we are going to see then. So as usual, both the way we will see how basically dot product you can perform by using the numpy, okay, numpy array, or you can perform by using the torch. Okay, the both the way we are going to take it here. Okay, so let us first create the vectors, okay, using the numpy, and then perform the dot product. Okay, so let us create the vector. So first vector I am going to create by using the numpy array, comma 3, comma 4. Okay, so another vector I am going to create using the numpy array, 1, comma 3, comma -1. So now you have created the two vector. Okay, so then how basically you can perform the dot product here? Okay, so simply numpy also having the some dot function. With the help of that particular dot function, you can perform the you can perform the dot product between the two vectors. Okay, so how? So dot product via function, or simply also like that also you can do. So let's say print, so np dot dot is there. Okay, np dot dot is there. So what basically it is going to take the two vector as a argument. So nv1 comma nv2. Okay, so two vectors you have created. Now you will see the answer is basically what, 7 here. Okay, so with the help of the function, like inbuilt function of this numpy array, right, you have performed the dot product. Okay, so similarly what you want basically, so manually you would like to perform the dot product. So how basically you can perform dot product via computation? So how basically you can perform? Can anybody tell me? So like, see, it is also giving you the some suggestion how you perform, right? So first what you will do, as I told you, right, so dot product basically what, so corresponding values you would like to multiply, like 1 into 0, 2 into 1, 3 into 4, 4 into -15. Okay, so first you perform, right, the first you multiply the both the matrices, both the vectors. Okay, so then you do the summation. So np dot sum nv1 and nv2. Okay, so then this is basically the corresponding values, like 1 into 0, 2 into 1, 3 into 3, and 4 into, and then whatever the results are coming, that you are going to just doing the summation. So once if you do the summation, so the same result you will get. Either you can use the dot function, or this manual also you can perform. So you can see that the resultant, this function, inbuilt function, and then manually both are giving you the same answer. Okay, so now coming to the how basically you can do by using using PyTorch. Okay, first how you can, so first what you will have to do, you have to create the vector. Okay, so nv1 torch dot tensor. Okay, so let's say same values I am going to take 4. So vector you would like to take, right? So 1, 2, comma 3, comma 4. So one vector you have created, nv2 torch dot tensor, comma 3, comma -1. Okay, so two vectors you have taken here. So then dot product via function. Okay, so print torch. Torch also has the same function as you have, as the numpy array is having. So torch also you can see already it is giving you the suggestion. Okay, torch dot. Okay, okay, so now you can see here torch dot dot. So first I have given this input, right? So input vector, this one tensor, and then another tensor. Okay, and then dot product via computation. Okay, so that via computation also, see, same way, first I have like to both the vectors like multiplied and then the resultant are added, right? So then here the summation is shown here. Okay, so now you see here every result, whatever the things you are seeing, even it is a scalar value, right? So how you are representing, like this is being represented by using the tensor only. Okay, so this is also the tensor and this is also the tensor. Okay, so now I hope this is done. Okay, so applications of the dot product, basically the dot product is computationally backbone for the many operations like statics, like correlation, least square error, entropy, principal component analysis. Similarly, signal processing, Fourier transformation, filtering for science background like geometry, physics, mechanism, linear algebra, projection, transformation, multiplication, right? So every field, like in the deep learning, like you are going to see like convolution model, like matrix multiplication, gram matrix. Okay, so all these, like whenever you are going to study this convolution, so you will require this dot product. Okay. Okay, so in this sub modules, basically, we have explored, right, various notations for the dot product, how to compute the dot product in vectors, okay, and matrices, and why the dot product is so important in human civilization. Okay, now coming to the Qs. Okay, now can you tell me what is the dot product of vector 1, 2, and 3, 4? First. 11. Many of you are saying 11. Yes, C is the right answer. Now coming to the second question, the result of the dot product of two vector is what? Scalar. Very good. Yes. If two vectors are perpendicular, then their dot product is what? 0. Yes. You have already seen this thing, right? Okay. So now you are given these two vectors like A 2 minus 1 3 and 4 0 minus 2. Then what is the resultant of fourth question? 2. Yes, 2 is the right answer. Okay, then next question is, what is the dot product of a vector with itself? B. Yes. Square of its magnitude. Yes, B is the right answer. Okay, so here are the answers. Okay. Okay, so now coming to the next module. Okay, so the next module is basically the matrix multiplication. So in this modules, you will learn about how to refer to the matrix sizes, the rule for the matrix multiplication validity, and one of the ways to conceptualize and implement the matrix multiplications, right? So of course, like like you have already studied this matrix multiplication, right? So matrix multiplications, right? So like two matrices are given to you, right? One matrix of size 2 cross 2, another matrix of size 2 cross 2, right? So how basically you can perform, right? So matrix multiplication between two matrices, right? So then this outer size of the first matrix should match with the inner size of the another matrix. Okay, so what does it mean? The number of columns of the first matrix should remain same the number of rows of the second matrix. Okay, then only you can perform the matrix multiplication to matrices. Otherwise, you may not be able to do it, right? So then how basically you perform the matrix multiplication? Let's say 1 and 2 is there, right? First row, first column. The resultant you are going to put here. Okay, first row, second column, the resultant you are going to put here. Okay, so similarly, so for second row, first column, the result 52, second row, and second column, the result. Okay, so because these things you have already seen, right? So, but in like how basically you can implement in the PyTorch, so that basically I'm going to tell you. Okay. Yeah, so let's see the matrix multiplication, what is basically the rule and how basically you can perform over here, right? So here you can see A, B, right? What is the size of the A? So the size of the A is 5 cross 2 and the size of the B is 2 cross 7, right? So the size, as I told you, right? So the number of columns of the first matrix should match the number of rows of the second matrix. So of course it is matching here, right? Can you see it here? So these are the matching here. Okay, so then definitely you can perform the matrix multiplication between these two matrices. And what will be the resultant matrix size? So the resultant matrix size will be 5 cross 7, right? The resultant matrix size is going to be the 5 cross 7. Yes. Okay, so similarly here, so the size of the first matrix is here, you can say 5 2 comma 7, and the A is the 5 cross 2, right? Can you perform right now the matrix multiplication these two matrices? No, right? So then how basically you can perform? You have to transpose this matrix as well as you have to transpose this matrix. Okay, so once if you perform this transpose here, so then it is going to be the 7 cross 2, and then another matrix is going to be the 2 cross 7, then only you can perform over here. Okay, so this is the way, like if like any of the compatibility is there, so you can transpose any of the matrix and then you can perform the multiplication between the matrices. Okay, so here also you can see here the matrix size, it was here 5 cross 7, the matrix size here 5 cross 2, right? So but you cannot directly multiply, but if you just do the transpose, now then what will happen? This matrix is going to be the 7 cross 5, right? And this is remain same. So then if you perform the matrix multiplication, then definitely the size of this matrix is going to be to the 5 cross 2. Okay. Okay, so here also you can see, right, the what is the size of this 5 cross 1, and the size of is here also the 5 cross 1. But right now you cannot multiply, right? This is not compatible. You can see it here. Okay, so then what you can do? You can just transpose these matrices. Okay, so if you just transpose these matrices, so it will become 5 cross 1. So then it is going to 5 cross 1. Then the resultant is going to be the 1 cross 1. Okay, so that you can do it here. Okay, so simple. This is also the matrix multiplication. So how basically you can perform the matrix multiplication over here. So same way. So these are the numbers are there actually, because I have downloaded. So this matrices, this just a minute. So here you can see 0, 1, 2, 3. So definitely like what you can do. So first row and first column. So 0 will be multiplied by A, 1 will be multiplied by C. Like first row, second column. So this is the result. Second column, first row. Sorry, second row, first column, second row, second column. Okay, so these are the result. Okay, so now let's see here then. So matrix multiplication, basically how you can do it, so that we are just going to see. So let's see here. Matrix multiplications. Okay, so let us first create some random matrices. Okay, so how basically you can create some random matrices, Okay, so A is the matrix. So sorry, first you can import the again two libraries, import numpy as np, import torch. Okay, so np dot random dot rand n. Okay, so let's say if I tell you 3 cross 4, okay, so let's say, so 3 random matrices you have created. Okay, so this is basically the random is the one function, right? So means inside that one more, like one class is there, inside one more functions you are calling random rand n. So basically this rand n, what basically it does, okay, so it is going to generate the number between Gaussian number between 0 to 1. Okay, remember the Gaussian number between 0 to 1. Okay, so randomly, and then 3 comma 4 you have written. So what does it mean? 3 comma 4 means, so the size of that particular matrix. Okay, so A, the size of, what is the size of that matrix A? 3 comma 4. So similarly the size of the matrix B, 4 comma 5. Similarly the size of the matrix C, what, 3 comma 5. Okay, so if you just run it there, sorry, let us print what is the size basically. So you can also see there are some function, matrix A has shape. So shape is the function. Okay, so here now you can see the shape. Okay, even if you would like to, print, so now the different matrices sizes are there. If you would like to print all the matrices, now you can see the data, right? So see the datas are there here. Okay, so all the datas are between here. Okay, so now you would like to perform the matrix multiplication. Now the question is that how basically you can perform the multiplication between these datas here. Okay, so now try some multiplications. Okay, so print AB is of shape. Okay, so that there is also one function is there. Okay, like in the NP, so matmul function is there. Okay, with the help of that matmul function, you can multiply two matrices. Okay, so NP dot matmul. Okay, so now let's see whether you can perform or not. Okay, first let us check, otherwise where we are getting the error. A and B is of size, right? So what is the size of the A? 3 cross 4. Okay, and what is the size of the B? 4 cross 5. So can you tell me whether you can perform the metric multiplication or not? Yes or no? Yes. Then what will be the size? 3 cross 5. Yes. So 3 cross. The resultant metric size will be the 3 cross 5. Okay. Now fine. Okay. So here the size we can write 3 cross 5. Okay. Now tell me whether you can perform between B and C or not. B and C. So what is the size? B. What is the size of B? Tell me. 4, 5. Okay. At the size 3, 5. Can you perform? No. Right? So definitely it is going to give you some error. Okay. Yes. So then is there an option like can you do some transpose and then you can multiply it? So some of you are saying that transpose C, right? So if you transpose C, yes, so definitely you can perform it. Let us check first what kind of error it is going to give to you. Yeah, see, now successfully AB is of size. Now this is done, right? Now you can see, observe it here, right? So you have successfully performed the dot product between the A and B. And what is the resultant output? 3, 5, as you predicted. You have also given the answer. But here you may not be able to perform, right? Because the size of the B is 4, 5, and the size of the 3, 5. So both 5 and 3 not compatible, right? So what you can do, you can perform some transpose here. Okay, yeah, so definitely now if you run it here, now see, now both the like B and C, you are successfully perform the dot product, and then you have got the answer here, right? So what is the answer now? 4 and 3. 4 and 3. Now again, you can you perform C between what C and A? So what you will have to do? Transpose. You have to take the C is basically the 3 cross 5, right, and 4. So C transpose, we have to take it here again, right? Then you can perform. Yes, now you can see after successfully you have performed the this operation. Okay, another way also, instead of using this, what you can do, so another way also what you can do, so print, so np dot round is a function, right? So directly A at the rate B and comma 2 you are writing here. Okay, so directly instead of using this function np dot matmul, so there directly there is a symbol, right, alphabet, which you can use, like at the rate you can use, and you can perform the multiplication. So this is also the same way as you are using the np dot matmul. Okay, and then you can round it. Okay, once you are performing and up to which decimal, like the resultant data you want. Okay, so that you can also fix it. Now you can see, so these are the data, and then again you wanted to take the shape. Okay, so shape also you can get it here. Okay, so 3, 5, so that also can be done it through it here. Okay, so now, so here now how using the using the PyTorch. Okay, so now first what you will have to do, so same way you have to create some random variables, right, of tensors, random tensors, then you can perform the operation. So let us create a one so A is equal to torch dot rand n, so 3, 4. Okay, B torch dot rand n 4, 5. Okay, C. Okay, so C is equal to torch dot rand. Okay. Okay, so now just see. Now you can see, now you have created the 3 tensors of different size, right? And then you can perform the operations. Okay, so now directly I am going to use the print np dot round A at the rate 2, sorry, B 2, and dot okay, so now you here, like you have performed the dot product multiplication between the A and B. Similarly, commands we should simple chat. What would be the recommended to beginners? Yeah, you can use anything, right? So what does the np dot round do? So np dot round, basically when you multiply, right, so the you will get some one particular number, right, 2.333333 or 444, like, so very big, right? So what you want, you would like to fix it. Okay, so then 2.3333 is coming. So then if you have written 2, right, so then it will give you 2.33 only. So 2 decimal, up to 2 decimal only, that number will be represented. Okay, so that is the functionality. If you like 3, so if you see here, every number, okay, so two numbers you can see it is fixed. Okay, the values are rounded. Yeah, that is there. So we will use the seed also, I will tell you, because that is the, I think, 11th or 12th module of the seed. So that's why I'm going to, let me complete this thing, then I will also tell you the what is the importance of the random seed. Okay, wait for time being. Okay, so now let's have the quiz then. So what is the conditions for two matrices A and B to be multiplied? Could you tell me what is the option correct? A, the number of columns in A should be equal to the number of columns in number of rows in B. Yes, correct. Okay, so now the second question is, so A is of 2 cross 3 matrix and B is 3 cross 4. What is the size of the product matrix A? B, right? 2 cross 4, right? So D is the correct answer. Okay. Now you tell me, is matrix multiplication commutative? Commutative means what? Whatever, if you are multiplying A into B, so will it be the same as the B and A? Yeah, sometimes true, right? Yes. Okay. So what is the result of the multiplying a matrix A with the identity matrix I? Fourth question. B. Yes, matrix A remains unchanged. Very good. If A is of 3 cross 2 matrix and B is of 2 cross 3 matrix, then what will be the size of AB? 3 cross 3. Yeah, very good. Okay, now coming to the softmax function. Okay. So in this some modules, basically, you will learn the mathematical formula for the softmax and interpretations and purpose of the softmax. Okay, so softmax function basically uses this natural exponent. Okay, so natural exponent you have already seen, that is basically that is represented by the E, and the what is the value of the E is 2.718 and so on. Okay, so here you can see, so this what is the property of the basic, first we will see the property of the natural exponent. So it is basically the strictly positive. Okay, and it never gets to 0. Okay, and these functions always be positive. Okay, and this natural exponent is used for softmax in order to generate the probabilities. Okay, so this is basically one of the most important function which is widely used in the deep learning. Okay, so that's why sometimes you may get confused, right? So you should know that what is basically the softmax and what basically you do with the help of the softmax. Whenever you are going to develop any model, okay, remember any model, so definitely you are going to implement, you are going to use these softmax functions. Okay, so you need to know basically what is this, and this softmax function uses this natural exponent, and the property of this natural exponent is it is a strictly positive. So here also you can see, right? So so this function, like with respect to the s, this is e to the power x, right? So it is strictly positive, it is never going to get down, right? All the time it is going to increase. Okay, it never, whatever the value you are going to give, right, minus, even minus, so the value will always be greater than the 0. Okay, and it will never be, and this function always be positive all the time, whatever value x of you are going to give, so the value of e to the power x is going to be the greater than 0. Okay. Okay, so now the softmax formula, so numerical examples, like you can see here, z is equal to, so let's say the three numbers are given to you. Okay, what are these three numbers? 1, 2 and 3. Okay, so then if you perform, so first you perform e to the power z. Okay, so means e to the power 1, e to the power 2, e to the power 3. Okay, so the resultant value of this 2.72, 7.39 here. Okay, and this is basically the 20.09. So what you have done, so e to the power, these three quantities are given to you, and then you have just performed you have just found the exponent of all the values. Okay, and then you are performing the summation. So summation of this one. So then after adding all these values, so you will get this one. Okay, so now what you will have to do, how basically the corresponding to this one, what will be the softmax value? Okay, so what will be the softmax value? Basically the e to the power 1 divided by e to the power 1 plus e to the power 2 plus e to the power 3. Okay, so that is basically the whatever the result you are going to get it here. So that basically call it as a softmax value of this corresponding to 1 is, and you call it as a sigma. Okay, so this is the sigma. Similarly, e to the power for this 2, e to the power 2 will come here, and the remaining thing will remain the same. Then if you perform this thing, so corresponding value is going to come the 0.24. Then similarly you can find 3. So for 3, e to the power 3 divided by e to the power 1, e to the power 2, e to the power 3. So then this value you are going to get it here. Okay, so corresponding to this 1, 2, 3, so now you are going to get some probability. Okay, so softmax functions basically what it tries to do, it converts real thing, right, real outcomes into the probability. Okay, so then with the help of the probability you can easily understand. Okay, so let's say, so you have developed some particular model. Okay, so let me take an example. So this is basically the softmax, right? So the way to think about the softmax function, so usually you give some things like 1, 2, 3, right? 1, 2, 3 as an input to the soft maximizer, and it is going to generate some probability. Okay, so probability of thing 1, probability of thing 2, probability of thing 3. So that is the basically the functionality of the softmax function. Okay, so now, so what we in the previous, like here we have computed, right? So this jet, this one jet you have passed through the soft maximizer, and it has converted to the softmax value or probabilities. So same thing here, 1, 2, 3 you have passed, and 0.09, 0.24 and 0.66. so these softmax values you basically here you will get it here. Okay, so now why do you need this basically? Okay, so here you see, okay, so this is basically the input. Each and every time you basically you feed an input to the feed forward neural network model, or you call it as a deep neural network model. Okay, so some number basically this model is going to generate. So let's say you have 3 classes. Okay, so one image you have passed, and you have only, so the image which you have passed may belong to 3 categories. One is cat, another one is dog, and another one is the horse, right? So then the model is going to generate some number. Okay, so this particular one image, it may belong to cat, like it has given some number 5. Okay, so it may belong to dog with a number 4, and this image may belong to horse with number 2, right? But human may not be a machine, or human may not be understand what is the meaning of this 4, 5 or 2, right? You may not be able to understand what basically these numbers are describing. Maybe sometimes 1000, maybe sometimes 10,000, this number can be given. But what is the meaning of this number, right? So that's why, so effectively, like the meaning, right, to say effectively what are these numbers. So again, these numbers are given to the, like when you develop the feed forward neural network. So in this feed forward neural networks, you are going to apply this softmax function. Okay, once this you apply this softmax function, right, so then it is going to generate some probability. Okay, so maybe this cat image may belong to 0.1% to the cat, maybe this image may belong to cat dog 0. some percent, let's say 2, and maybe this image image may belong to 0.7. Okay, now this is the now reality, like 542. Now you will not be able to understand. Now easily now you can understand. Okay, why seeing this probability? Okay, definitely the higher probability means the higher chances of like this particular cat belong to the which class, then horse class here. Okay, so similarly this horse, if you pass, then optimizer is going to give you some probabilities. Is it clear? Yeah, so now here you can see, so if you pass actually this 542 number to the soft maximizer, now see here you can see some probabilities are given. Okay, now here you can see higher the probability for the cat. Actually this cat belongs to this particular class, so then definitely you can say that okay, so the chances of like this may belong to cat is higher here. Similarly for horse, like horse probability is very high here. Okay, for the similarly for again horse here, so here you can see here 50-50, it may like looking like cat or this thing. So these numbers basically can be generated with the help of this soft maximizer. Okay, so now you will see the code then here. Okay, so basically because due to the constraints of the time, what I'm going to do, so we have already implemented or taken some code, so directly we will try to run this code then, because it will take the time otherwise. Yes. Definitely we will share. Slides. Okay, so now and because we have very less time now, so that's why. Because if you are running more and more, this Google Colab notebook, so then sometimes you may not be able to run, so you have to terminate these sessions. Okay, just remember, now then only you can connect it. Okay, now yes, so here also again same libraries like NumPy you are using, torch you are using, and then one more class, right? NN, you have created one object here. Okay, so that I will tell to you why you have created this particular object and what you can do with the help of this particular object. Okay, so just I'm running this particular code. Okay, so now what I'm trying to do, okay, so here Z1 variable as you have taken, so where you have taken these three numbers, okay, 4 minus 50,000 and 8. Okay, so as you have seen in the slide as well. Okay, so then what you will do basically, whatever the number exponent you usually take. Okay, so np.exp, if you just take it, so it will find out the exponent for every number. Okay, so for exponent, as you can see here, so exponent of 4 is like 0.017. Exponent of this one, sorry, this is the output. Okay, so you will take the exponent of all these number and then you take the summation like the sigma, the denominator you just, this is the numerator, and then what you basically try to do, So each number, right, exponent, you divide by this denominator. This is the summation value, right? Okay, then basically you will get it this sigma. Okay, so as the equation also, as you can see, so this is z you have taken, then ez you have found, right? So this is the ez you have taken, then summation you have taken it here, then ez divided by e to the power, sorry, summation of e to the power z. So then you can find out the softmax function of softmax value of each and every input or each and every things, right? Okay, so then I have printed this z and then sigma. Okay, so this sigma I have also printed, right? So this is the sigma, right? So means softmax value, and then summation. One more point I forget to tell you, that the summation of these probabilities. Okay, so this summation of the softmax value will be 1. Okay, so you can just add all those probabilities, so then definitely it is going to be the 1. So after doing these things, as you also can check it here, the sigma, right? So np dot sum, I have taken it here. If I just run it here, so as you can see, corresponding to 4, now the softmax value is this much. Corresponding to this minus, so now it is very less value, right? So then the softmax value, right, it will never get to the, less than the 0, negative, right? So that's why you can see it is 0 point something, 0 point, right? And corresponding to 8, so higher probability it is giving. Okay. Okay, so that you can also do, right? So this you can also find repeat with some random integers as well. So here with the help of the numpy, np dot random dot rand int, right? So minus is the minimum value and higher value is the 15. So 25 numbers will be generated between -5 to 15 here. Okay, and then again exponent you take, then summation you take, and then you can find out the sigma. Okay, then what you can do, so between this z and this sigma, okay, the probability and these things you can plot here also the this one here. Okay, so here basically if you plot it here, actually, okay, so now you can see how the values, right? So 25 values you have generated between -5 to 15, right? -5 to 15 here. So now how the values of the softmax sigma. So as you can see, how like this is the exponential curve you are getting, right? So initially for the small notch, now you can see a small increment, right? For bigger value, right? You can see how suddenly it is getting exponent, right? So this graph it here. Okay, and the summation, if you take the probability of all the 25 numbers, so definitely it is going to be the 1 here again. Okay, now same thing you would like to do with the help of PyTorch. So okay, so when you want to do this thing with the help of the PyTorch, okay, so here basically you can use directly some functions. Okay, so some objects, as you have already created the nn objects, so nn object directly have the this softmax function. Okay, with the help of this softmax, you can create the object, so you can call this particular class softmax. Okay, and you can create the object. Okay, and then you can pass this tensor z. You first z value you have taken here, right? 25 numbers. Okay, then you have converted, because it was the integer, then you have converted it into the tensor. Okay, and then you have passed it through this softmax, and then if you pass it there, so then corresponding directly you need not to create individually exponent of each and every number, and then you do the summation and then you divide it and then you will get. So directly you can call this particular function. Okay, and then you can pass it and you can directly get the probability. And to make sure that whether it is correct or not, so you can also do some addition operation and you can get it here. Okay, so this is basically the softmax function. What about all those things? Okay, now let's have the cues then. Okay, so what is the primary role of the softmax function in the machine learning? Can anybody tell me? A, yes, many of you are saying A. Yes, to normalize a vector into probability distributions. Yes. Okay, now second question. The softmax function outputs values that are basically, what is the option? Between 0 and 1 and summing to 1. Okay, so C is the correct. Is softmax function, so just like this is the sigma, okay, and z I, right, and e to the power zi, and this thing, so strictly monotonic with respect to each input zi. So which option is correct? Option A, strictly increasing in zi, right? So A is the correct. Okay, if two inputs to the softmax function are equal, right, so what can be said about their output? A, again you are saying A is the correct. Yes, their outputs are equal, like sigma zi and sigma zj, right? Now the third one, is the softmax function convex with respect to the input vector z? Which option is correct? Always convex? No. Always concave? No. Convex only for positive inputs? No. So basically the option C is correct. Neither convex or nor concave. Okay. Okay, so these are the basically the right answers. Okay, Janil Patil, we will respond you at the end. Okay, so that you are mixing RGB or those things. Okay, we will tell you. Okay, now coming to the logarithm. Okay, I hope you have already used many times the logarithms, right? So logarithms also is widely used in machine learning and deep learning techniques. So what are the properties which make so popular these logarithms to use in deep learning techniques? Okay, so those points basically I'm going to discuss with you. Okay, so in this some modules, basically, you will learn the logarithm function. Okay, what are the logarithm functions and why logs are often used in ML and optimization. Okay, so now you have seen, right? So this is the exponent. Okay, if you take the inverse of the exponential, then it will be logarithm, right? So inverse, like if you take the inverse of the logarithm, so then it will be the exponential, and if you take the inverse of the exponential, then it will be the logarithm. Okay, so here you can see, so log is basically the monotonic functions of x. So what is the meaning of the monotonic? Means always it is increasing, right? Non-monotonic means sometimes it increase, sometimes it decrease. Okay, so monotonic, so log is basically the monotonic functions here, right? And second one, this is important because minimizing x is the same thing as the minimizing the log x, right? If you are minimizing this x, so it will remain same as the minimizing the log of x as well. So this is the important, okay, because of this monotonic property. And log stretches small values of x. Okay, so here you can see, right, you might have observed here for the small notch scratch. So for 0.01, from this 0.1, right? So see how much there is a increment in the y-axis. So of course, like if you see from this year -10 to -7, right? So 5 or 6 times, right? 5 and 6 numbers, it is increasing for a very small value. Okay, for slowly, like it is decreasing. For if you see 0.8 to 0.8 to 1%, so you see minimal like 0.1 some percent is not at all increasing. right? For the smaller values, right, for it is stretching too much. Because of this property, right, for the smaller values there is a major effect in the log of x axis. Okay, so this property makes it popular, right, to use in, like, machine learning and deep learning, right? So because most of the times, right, so you may be dealing with the errors, right? So what you basically want, so error is very important property, right? That basically that particular error you would like to minimize, right? So in all the machine learning and deep learning models, basically you would have some error, and that error you would like to compensate, or you somehow you would like to manage, even if it is a very 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 small error, right? So with the help of these functions, it will be treated that it is a very big. So here also you can see, even though very 0.01% error is there, like, but how much, like, it is giving the weightage to in the log of x, right? So it is too much here, isn't it? So this property makes it popular to use in deep learning and machine learning popular. Okay, just 1 minute, guys. Just take a 1 minute break. Okay, 5 minute you may take the break, so that okay, 5 minute you just take the break, then come, then let me complete these things, because I have a more content to teach to you. Okay, 5 to 10 minutes you can take the break. Welcome back, participants. Now let's get started. I hope my screen is visible. Is my screen visible? Yes, okay, thank you. Okay, so now logarithm functions like ML and DL often involves minimizing small quantities like probabilities, right? And computer suffers from precision errors when working with very small numbers, right? So now let's see the code then. Recording one. Okay, so as usual, we have again imported one library here. Oh, 1 minute. Okay, so here we are using the one more library, matplotlib.pyplot as a PLT for for the purpose of plotting the graphs. Okay, so first line here you can see. So we have generated a number between 0. Uh, like 0.001 1 between 1, right? So 200 numbers we have generated here. Line space, basically this function basically generate these numbers here. Then when we are printing those numbers, what are those numbers basically? And then this we are passing through the log function. Okay, so once if you pass through this log functions, and then you can plot it. Okay, so sorry. Okay, so these are the basically the numbers. So here you can see for a small notch only, right? So how like there is a change in the y-axis. Y-axis means log of x. Okay, so like this is basically the log functions for small values of x. Now it is taking treating like like it is giving more weightages, and there is a huge changes in the log of x axis. Okay, so similarly again you have generated 20 numbers here. So I told you, right? So if you take like a log of x, and again if you take uh, the number like uh, if you plot the graph between this log of x and exponent, right? They are both are inversely proportional, right? So then you will get the straight line here. So now you can see log of x you have taken, right? And again you have taken the exponential. So now you can see this is also like same, like unity, right? So same value you are going to get it here. Okay, again you have taken the exponent of x, and then again you are passing it to the log function. So both are remains and no impact, right? So straight line you are going to get. Okay, so slope you are going to get it here. Okay, so now in this some modules you have learned that the logarithm function and why logs are often used in the ML and optimization. Okay, so now there is a quiz. So what is the inverse operation of a logarithm? Can anybody tell me? Am I audible? actually. Okay, so now second, which of the following is true about the logarithm 1? अच्छा यही पर ऑप्शन आ रहा है. Okay, 0. Okay, very good. Okay, so what is the value of log 10 to power means log 100 base 10? 2 or 10? Right, 2. Okay, 2 is the correct one. What is the primary purpose of the logarithm? Which of the following is correct? To multiply numbers or to find the exponent to which a base must be raised to produce a given number. Right, P is the correct. Okay, what does the logarithm base 10 represent? Natural logarithm or common logarithm or binary logarithm? Yeah, common logarithm. Okay, so here you can see the answers then. Okay, so now coming to the entropy. Okay, so next module is the entropy and cross entropy. So in this submodules, basically you will learn how to interpret entropy and what is the formula for the entropy and the main application of the entropy in deep learning. So entropy means, like you can see stable things, right? So initially the things are very stable, right? When these things become scattered, okay, so then this is like some randomness or some scatteredness comes, okay, so then only the entropy comes into the pictures. Okay, so here you can see, so all the like symbols, right, different symbols are there. Okay, so they are well arranged. Okay, if they are well arranged, right, what does it mean? Like there is a low entropy. Okay, once they are scattered, right, here you can see, okay, so then you can say that there is a high entropy. Okay, so this basically, the entropy, uh, the first time who introduced like this Claude Shannon, okay, who basically he introduced this entropy concept. Okay, so entropy in information theory, basically entropy is a measure of uncertainty or randomness in the set of outcomes. Okay, so how much, like there is a uncertainty, or how much there is a randomness is there in the output, or in the real world. Okay, so that randomness can be measured with the help of this entropy. Okay, so it is often used to quantify the amount of information contained in the message or a random variable. Okay, and high entropy means high unpredictability or disorder, while low entropy means low unpredictability or more order. Okay, so if I tell to you, right, so tomorrow tomorrow is going to rain. Okay, so what does it mean? Because right now the summer season is going on, right? So definitely, so this is a, like if tomorrow it is raining, so definitely there is a huge information, right? So then what does it mean? There is a huge entropy. Okay, if let's say tomorrow will be sunny day, if I tell you, so there is no meaning. Okay, there is a redundancy. This is a as usual things. If the things are as usual, right, so definitely then there would be the more less probability. Okay, so less information is there. Okay, so tomorrow, let's say China is going to attack, or America is going to attack India. Okay, so what does it mean? Then there is a huge information. Okay, so if I talk about the Pakistan attacks, so daily, like we have a conflict between India and Pakistan, right? So this is not like meaningful information. Okay, if there is a meaningful, like something random happens, okay, so then there is a huge information, and then you will call it as a higher entropy. Okay, so like Donald Trump, what it says, right, no one believes, right? So nowadays, like sometimes he changes his statements again and again, right? But some statement is given by our prime minister, right? Then there is a huge weightage, means something will definitely happen. Okay, so what is the meaning? Then there is a huge meaning. Okay, so that is the meaning of the entropy. And remember that the highest entropy is going to be the 0.5. Okay, it may lie between 0 to 0.5. If higher entropy means, if we are saying that 0.5, and lower means it can be 0 as well. Okay, so this is basically the formula of the entropy. Okay, so now here you can see the probability of xi and the log of pxi. If I take a very simple example, so let me take an example here. Let's say flipping a coin. Okay, flipping a coin, two outcomes are possible. One is the head and another one is the tail, right? So head, when it comes the head, so what is the probability of being a head? Okay, then log, then what is the probability of being the head? Okay, so let's say 0.25% is the probability, then 0.25 log 0.25. Okay, then this is for the one outcome. And what are the another outcome? 10, right? So then what is the outcome? What is the probability of being a 10? 0.75. Okay, so then you will do summation, right? Then 0.75 into log 7.25. 0.75. Okay, then you do the summation. Okay, so then that is going to be the entropy. Here also we are going to take the negative signs. Why basically you are going to take the negative sign here? Because if you take this 0.25 log of this, then this value is going to be the negative. Okay, so then that's why you are going to make it as a positive. Okay, so that's why here you are going to take the one more negative symbol over here. Okay, so that is basically the entropy that we call it as a entropy. The high entropy means the data set has a lot of variability. Okay, so like, and low entropy means that the most of the values of the data set repeats. Okay, so there is no meaning. Okay, therefore the redundant. Okay, so basically here you have two important points you have to remember. How does the entropy differ from variance, right? That we will see. Entropy is non-linear and makes no assumption about the distribution. Yes, and basically entropy is non-linear and makes no assumption about the distribution, but variance depends on the validity of the mean and therefore is appropriate for roughly normal data. Okay. Okay, so this is basically the simple entropy, right, for the one distribution. Okay, if you have a two distributions, okay, so then the cross entropy comes into the picture. Means you would like to see how two distributions are different. Okay, you would like to find out that how the two quantities of two different data sets, they are different. So with the help of the cross entropy, you can compute it. Okay, the cross entropy basically describes the relationship between the two probability distributions. Okay, so here you can see P log Q. Okay, so this is the P is the probability of one distribution and Q is the probability of the another distribution. Okay, so now let's see the code then. Yes, so P of X can be considered as the probability. That's why I told, right? Softmax function basically is going to give you the probability, right? And then this probability can be given to your this cross entropy or entropy particular function. Okay, so as usual, again, you have imported NumPy as a NP and matplotlib.py plot as a PLT, right, for plotting that particular graph. Okay, so let's see here, probability, okay, flipping one particular event. Okay, so probability of an event happening is P is equal to 0.25. Okay, so now what is the formula? The formula is P of X, right, log of P of X. Right, I have just and negative of this one. So H is equal to minus P of P asterisk and P dot log of P. Right. So can you tell me, is it correct? Is this the entropy correct? So the entropy which I have computed here, is this correct here? 0.34. Is this entropy correct? No. Why no? Okay, so now it is not correct. Okay, because you have taken only the one part. Okay, the probability you have taken only for the one part, right? So because you have not taken another part, let's say if you are flipping the coin and the probability of being a head is 0.25, right? As I told you, right? So all the probabilities you have to compute. That's why we have taken here the summation. Okay, so all the aspects you have to take it here. Okay, so then only you can compute the entropy. Okay, so that's why now again another, like for one event only you have taken, but what about the another event here? So right, another event could be like 0.75 here. So that's why again what you have taken, so you have taken another event. So that's why this one is not the correct. So another, like being a head is 0.25%, and then another event will all definitely will be there. Okay, so what is that particular another event is? So 0.75. Okay, so 0.75. Okay, so then how you can compute that? So h is equal to, so like all the values you are taking one by one, right? So 0.25 you have taken, so 0.25 into log of 0.25. Okay, then minus, because here you can see there is a minus sign is there, right? And then again for the next value, right? So 0.75. Hello, am I audible? Sorry for the disturbance. Actually, the electricity gone, so that's why we were disconnected. Yeah, okay, so let me finish this topic, then maybe we can start tomorrow then. Okay. No, not yet over. Let me just finish this entropy. Okay, fine. So I hope, am I audible clearly now, right? Hello? Yes, yes. Okay, thank you. Okay, so now as I told you, right? So here you can see the entropy, right? So this is basically the correct entropy. So you have to take both the aspects of the coin, like flipping being the head and being the tail, right? So once if you find out both the summations, then definitely you are going to get the right answer. So okay, so if you just run it. Okay, so now then 0.56 is the right answer. Okay, so another way also, like manually also you can write it down. So in this way, like uh, because the flipping the coin, only two aspects are there, right? So being a head or being a tail, right? So here like P into NP, like log of P, right? And then 1 minus P. So this is basically the formula, right? So that you can take, and then also you will get the same, either you can write in this form or you can write in this form, so you will get the definitely the same answer. Okay, so another, like I told you, right, the cross entropy. So cross entropy means finding the, how like one distribution is similar to another distribution, or how one distribution is dissimilar to another distribution. So here, like one probability distributions, like P is equal to 1 comma 0. Okay, so means only one event is there and the probability is 100%, right? Another event is there, right? The probability of being another distribution is there. The probability of being one part is 0.25 and another part is 0.75. Okay, so now how you can find out the cross entropy, right? So now same way, like you can find out only two aspects are there. So I is equal to 1, right? Then P of I means like 1 into NP dot log 0.25. Okay, then plus, okay, then P is equal to, like P of I is going to be 0, and then NP log is going to be 0.75. Okay, so if you do this thing, right, so then that would be the cross entropy. Okay, so now you can see 3.68 is the cross entropy. Okay, so now the question here is, right, so would, like right now you have taken the cross entropy between like P to Q. Now, can you tell me, is it symmetric? When you take the Q cross entropy between Q and P, will it remain the same? Yes or no? How many of you are saying say yes? No, right? It will definitely be different. Okay. So now you can also check it here. So let's say if I make it as a, right now 1.36 you are getting. So if I make it as a Q, if I make it as a Q, and then let me run it again. Okay, because here the 0 you may not be able to divide it, so that's why you are going to get it here, the error here, right? Okay, because here, so log of 0 you are getting, and then you are going to multiply, so because of that runtime divide by 0 encountered in log, so you are getting the here. So definitely then the cross entropy between P and Q will never be same as the Q and P, so definitely it may not be the it will be the symmetric only. Okay, so how basically you can measure why? So here it is also for the two events, right? uh, so this particular formula, right? So same formula you can also write in without this for loop, right? So here like you can write it down, okay? And then because another event is 0, right? So here as we have taken P and Q, okay, because the another quantity is this P is going to be the 0, right? So because of that, so one term will be 0, okay? So that is, these terms can be simplified to the very small terms like h is equal to minus np dot log of q of 0. Okay, so that is the same way. Here also you can write like this, or here also you can write like this. Okay, this is because of p of 1 is the basically here 0, and if you multiply 0, then this term will become the 0, and you are left with only and p of 0 and 1, so then it is going to be 1, and then np dot log q of this one, so 0.25. Okay, so then you are going to get this answer. So how basically this cross entropy you can implement? So first so there is a one function f, okay, which basically has the binary cross entropy. Okay, so here of course like you have a two list here p and q, then now you have converted them by using the tensor and torch dot tensor, right? And then you are going to find out the probabilities, like then you can use the f dot binary cross entropy, right, between this q tensor and p tensor. Okay, so then same way you can do it here. Okay, so now you can see again you have got the same answer. Okay, so same things you can also implement by using the torch here. Okay, so now in this some modules you have learned like how to interpret entropy and the formula for the entropy and the main application of the entropy in deep learning. Okay, so this is one of the most important function, because see why when you are going to use this entropy function, so you are going to train your model, right? So let's say you have a 3 class, right, cat, dog and elephant, and you are training your model with the help of these samples, right? And the model is going to predict some values. So definitely the earlier models predicted like 1, 3, 4 kind of output, right? So that output you have passed through the soft maximizer, and then those values converted into the probabilities, right? 0.1, 0.3 or 0.7 something, right? So these are the probabilities you have got. Okay, and then the 3 events are there, right? And then definitely you have some original probability. Okay, original probability like one cat you have so let me show you with the example here. So let's say you have a one model, deep learning model. Okay, so you have a given the cat, dog and elephant. Okay, so let's say first time you have passed the one cat images, then model has predicted some number, let's say 4, 3 and 2, right? So definitely this will be passed through the soft maximizer. Okay, so then for each category, like how many categories are there? 3 categories are there, so they will be converted. Let's say this is going to be 4 is going to be converted into 0.7, and then 3 is going to be converted into the 0.2, and then this is going to be converted to the 0.1. Okay, so these are the probabilities are predicted by what? Your model. Okay, but you already know what is the probability of that this is being a class, you already know, right? So original level, so 1 is there, and being a dog is 0, and being a eat means elephant is the 0. Okay, so now what you can do, you can perform, right, cross entropy between these, because this you already know this probability, that okay, surely you know that this the image which is passed, right? So this is labeled information, that this is already cat. So that's why one probability you have given. So you can find with the help of this cross entropy function, like 1 log 0.7, 0 log 0.2, and 0 log 0.1. And whatever the summation is coming, that is going to be your what entropy. Okay, so this is basically the application. And then like here you can write it like this: 1 into of 0.7 plus 0 into right log of 0.2 plus 0 into log of 0.1. Okay, definitely it is going to be 0. It is going to be 0. You are left with this term. Okay, and then you are going to multiply it by minus. Then this is going to be basically the your error. Okay, so that basically you would like to compensate, right? If let's say if it has predicted where means instead of 0.7, if it has predicted only 1, okay, so then definitely what will be the error? Can you tell me what will be the error then? Zero. Yeah, definitely the error is going. Then what does it mean? Yes, so what does it mean then? So definitely the model has learned. Okay, it is predicting the correct answer. Okay, so that therefore the error is going to be the 1. Yes, it is means the correct classification. Okay, okay, so now let's have the quiz. Then today's session we will end. Then from tomorrow onwards, like 4 modules of this, so for some modules of this module is left, and along with the tomorrow's module 2. So both the things I will cover in tomorrow's session. Okay, so now which of the following distribution has the highest entropy for a given number of outcome? So can anybody tell me what is the answer? B, D, B, D, A. A is the correct answer. Okay. Uniform distribution is going to be have the highest entropy. What is the entropy of a system where the probability of all outcome is 1? Someone is saying 0. Okay, you think about it. Okay. The entropy is maximum when all events have equal probability, or one event is more likely than others, or only one event occurs. A is the correct, right? Which scientist introduced the concept of entropy in information theory? Isaac Newton, Albert Einstein, or Claude Shannon? Yeah, Claude Shannon, right? Okay, so what does entropy measures in information theory? Speed of transmission, amount of noise in signal, time taken to compress data, or average amount of information in a message? Amount of noise, no. D, yes, D is the correct answer. Okay, now you can see all the options then here. Okay, so yeah, I taught myself here. Okay, so thank you very much, all the participants. I hope you enjoyed all the sessions, right? Means morning session as well as the evening session. Yeah, definitely. What I will do, see, I have prepared the slide in such a way. Okay, I will share with this thing. So here you can see. So in each and every code, so a code is there, so the code is already written. Okay, so you can rerun, you can download this particular code, okay, and rerun it, don't modify. Okay, so you can rerun all the codes whatever we have written, so are already there. If you would like to practice, right, whatever practice we are doing, I am writing. So p code means practice code, and this is the actual code. Okay, So both code are there. So I will share with you the PPT. So please rerun and revise all the concept, right? So those concepts are very helpful, like when you are going to develop the models. Deadline, extension. Okay, we will think about it. Okay. Yeah, all these things will be shared in the, your canvas. Yes, definitely. You are going to, like last week, basically all the application sessions, and you have to, we will give you how to implement all the projects. Okay. That we will give you that time we will give you all the guidelines. Okay. How to develop, what topic you have to select. Okay. How much, like, you are going to, novelty you should have, what topic you should select. All those instructions will be given to you in the last week. Okay. And thank you very much, guys. So now we will see you then tomorrow.